50 years from now, Voyager will be the science project of the 20th century. The mission, the big mission. Uranus was a small bluish-green dot in the telescope, and Neptune was an even smaller bluish dot.
"45 years ago, a spacecraft was launched with the intention of exploring specific regions of space. Little did anyone anticipate that it would continue venturing into uncharted territories long after its expected lifespan. Now this audacious NASA mission is defying conventional limits and revolutionizing the realm of space exploration. And here's the mind-blowing part. Not only is this intrepid spacecraft billions of miles away from its launch site, but it is also transmitting data back to Earth using technology that is more outdated than a vintage cassette player. It's truly astonishing. However, there's more to the story. Elon Musk has just disclosed something deeply unsettling about NASA's groundbreaking mission, initiated in 1977. What has Musk revealed? And what could this hair-raising discovery from the outermost frontiers of space mean for us here on Earth? Join us in today's video as Elon Musk unveils Voyager's chilling new revelation in the vastness of space. Elon Musk is a man with a busy schedule, and despite being a true nerd, he still finds time for his passion, space travel. Being a devoted follower of the Voyager probe, he has a personal connection to its launch during his childhood. As an adult, Musk shares several similarities with the Voyagers, including launching rockets from the same location where they embarked on their iconic journey. It's truly astonishing that these spacecrafts, still operational, continue their endeavors in space, even with Musk surpassing the age of 50. Let's transport ourselves back to 1965, a pivotal time in space exploration. Gary Flandreau, an ingenious mind at NASA's Jet Propulsion Laboratory, had a momentous task, charting the optimal path for a space probe to reach the distant giants of our solar system. Utilizing a trusty pencil, Flandreau made a staggering discovery. He realized that in the late 1970s and early 1980s, a rare alignment of the four gas giants, Jupiter, Saturn, Uranus, and Neptune, would occur, creating a celestial necklace with the Earth. This extraordinary phenomenon presented an opportunity for a spacecraft to gain speed boosts from gravitational pulls, akin to being guided by an invisible rope. Flandreau calculated that what would have taken 30 years to journey from Earth to Neptune could now be accomplished in just 12 years, thanks to these gravity assists. However, this celestial alignment only happens once every 176 years. Seizing this extraordinary chance, NASA promptly took action. Within a mere 15-day interval, they launched two identical spacecraft, Voyager 1 and Voyager 2, in the summer of 1977, aiming to maximize the potential of this cosmic alignment. Little did they anticipate that these twin explorers would surpass all records in space mission history. More than 45 years later, Voyager 1 and Voyager 2 continue to thrive, transmitting groundbreaking data from the farthest corners of our solar system on a daily basis. They have outlasted any other spacecraft, defying expectations by traveling farther than anyone could have imagined. This remarkable achievement is even more astonishing considering their initial mission duration was intended to be only 4 years. However, these interstellar pioneers had surprises in store. Early on, they provided astonishing up-close views of Jupiter and Saturn's moons, revealing a dynamic and active world that exceeded all expectations. By uncovering active volcanoes and fissured ice fields, the Voyager spacecraft revolutionized our understanding of these distant realms. Voyager 2 embarked on an unprecedented journey, venturing close to Uranus in 1986 and then successfully passing by Neptune a mere 3 years later. It remains the sole spacecraft to have traversed such uncharted territory, astonishing physicists with remarkable discoveries over 14 billion miles away from Earth. These trailblazing interstellar probes, no larger than a vintage Volkswagen Beetle, continue to defy expectations and expand the boundaries of our knowledge. The epic expedition of the Voyagers commenced with a never-before-attempted gravity assist from Venus as they ventured towards Mercury, establishing themselves as true pioneers. However, this feat was no easy task, with small margins of error measured in tens of minutes, necessitating multiple attempts to achieve success. On their way to Jupiter, the initial leg of their voyage took them 10 times farther from Earth than Mercury, requiring navigation through the perilous asteroid belt, a subject of much speculation and debate beforehand. During the 1970s, Pioneer 10 and 11 successfully traversed the supposedly dense asteroid belt, paving the way for Voyager. Yet Voyager encountered further challenges. With a mere 69 kilobytes of memory, equivalent to a fraction of a smartphone's capacity, the Voyager computers relied on onboard intelligence to manage the intricacies of their journey. The data collected by the onboard instruments was stored on 8-track tape recorders before being transmitted back to Earth via a modest 23-watt transmitter, comparable to the power of a refrigerator light bulb. Equipped with 12 feet wide dish antennas, the Voyagers employed radio communication, travelling at the speed of light to send and receive messages. However, their vast distance from Earth, progressing at a rate of 3 to 4 light seconds each day, posed challenges in maintaining connectivity. It took over 18 hours for signals from Voyager 2 to reach Earth, and the increasing interference from terrestrial noise, including radios, televisions, cell phones and more, made it progressively more challenging to discern the faint whisper from the spacecraft. Nevertheless, despite these obstacles, the Voyagers have surpassed expectations and continue to astound astronomers with unexpected discoveries in the vast expanse of interstellar space. Their remarkable journey has reshaped our understanding of the cosmos and expanded our knowledge of the enigmatic realms beyond. And now Elon Musk has just dropped a bombshell about the Voyagers. Beyond our solar system lies the enigmatic Oort cloud, a gathering of comet-like entities held together by the Sun's gravity. It extends halfway toward the nearest star, a distant realm that the Voyagers are steadily approaching. Interstellar space, where the solar wind subsides, becomes a more accessible frontier. The heliopause, marking the border between our solar system and interstellar space, introduces uncharted territory. Initial estimates of the heliopause's distance were inconsistent before the Voyager probes reached it, but assuming it to be around 50 astronomical units (AU) led to increased mission funding. However, as the spacecraft departed from this landmark, scientists and experts from SpaceX were left bewildered by the absence of expected signs of interstellar transit. One anticipated indicator of crossing into interstellar space was a sudden surge in galactic cosmic rays, energetic particles ejected from supernovae and other cosmic cataclysms at nearly light speed. Yet the massive magnetic shield of the heliosphere deflects most low-energy cosmic rays, safeguarding our inner solar system. The Voyager team closely monitored changes in the prevailing magnetic field as the spacecraft ventured further. The interstellar medium, consisting of ionized gases influenced by neighboring stars, was expected to exhibit a distinct magnetic field orientation compared to the heliosphere. However, the Voyagers reported no such changes, intensifying the mystery. It was on August 25, 2012, that Voyager 1 finally breached the heliopause, transmitting intriguing data back to Earth. While it confirmed the anticipated rise in plasma density, there were no indications of a shift in the ambient magnetic field's direction. This came as a surprise, as it was assumed that transitioning from a region dominated by the Sun's magnetic field to one influenced by other stars would bring about a change in magnetic field orientation. In November 2018, Voyager 2 embarked on an extraordinary voyage to the interstellar frontier, reaching the heliopause, the boundary of our solar system, 120 AU from Earth, matching its twin's distance 6 years earlier. However, scientists were perplexed as Voyager 2 observed no magnetic field changes as predicted by theoretical models, adding another puzzle to the equation. The expected fluctuations in the heliosphere, influenced by the Sun's 11-year cycle and similar to the solar wind's behaviour, did not align with the data. Surprisingly, the solar wind was at its strongest during Voyager 2's arrival, suggesting that the heliopause should have been farther than 120 AU. As the Voyager probes approach the interstellar medium, their data uncovers intriguing small-scale variations near the heliopause resulting from interactions with the heliosphere. Yet on a larger scale, the magnetic field exhibits minimal changes. This raises questions about whether the spacecraft will eventually leave these turbulent shores and encounter the genuine interstellar magnetic field, or if our current understanding of the situation is entirely flawed. Some experts speculate that the Voyagers might still reside within the heliosphere, while others find support in the significant rise in galactic cosmic rays and plasma density detected by the probes aligning with the prevailing viewpoint. Solving the fundamental puzzle of the heliosphere is like trying to see a goldfish bowl from the fish's perspective. An interstellar probe is needed for an external view. Despite technologies like answering machines, VCRs, and pennies becoming obsolete, the Voyagers defy the odds with their outdated yet resilient systems. These spacecrafts operate on 50-year-old technology, minimal software, and lack complex lines of code. Voyager 2 has 5 functional instruments, while Voyager 1 has 4, all powered by converting heat from plutonium's radioactive decay into electricity. However, NASA has entered triage mode as the Voyager's power output declines by around 4 watts annually. 3 years ago, engineers had to deactivate the cosmic ray detector's heater, crucial for heliopause transit analysis. Remarkably, the instrument continued functioning beyond its tested limits, enduring extreme temperatures. The magnetometer and plasma science instrument are expected to be the last to shut down, benefiting from the heat generated by the computers within the spacecraft, unlike the other instruments located on a 43-foot-long fiberglass boom. So what lies ahead for the Voyagers? If all goes well, their missions could be extended until 2030, with power being the determining factor. Undeterred by challenges, the Voyagers will persist, embarking on a mind-boggling 16,700-year journey for Voyager 1 to pass Proxima Centauri, our closest neighbouring star. Voyager 2 will follow suit 3,600 years later. Afterward, they will continue orbiting the galaxy for millions of years. Long after our sun has faded and the heliosphere has dissipated, these resilient spacecrafts will endure, largely intact, unlike our small blue planet. Perhaps they might even convey a final message during their eternal odyssey, though not transmitted by humans or over the radio. The Voyager's saga remains a testament to human exploration and scientific curiosity, defying the limits of time and space. Now share your thoughts on the Voyagers in the comments below.